Hi everyone. In the earlier video, we covered topics related to matrices, introduction of matrices, algebra of matrices, matrix multiplication, and so on. In this video, we'll cover determinants. That is, what is a determinant, how do you expand and evaluate a determinant, and what are the properties of determinants. So we'll go through all the properties of determinant with few examples. Determinant is a mapping function from set of matrices to set of real numbers. There is a way where we associate a real number to this particular matrix. So basically you do a certain set of calculation so that you will get one number for this particular matrix. That number or that real number is nothing but the determinant for this matrix. Determinants are used in solving linear equations. For example, 3x plus 2y is equal to 5, 2x plus 5y is equal to 10. So here if we have to find the values of x and y, then we can use determinants. Determinant is denoted using this particular symbol, right? And for a matrix normally we use square brackets. For determinant, we use two straight lines like this. Now let's take an example. Let's take 2 by 2 matrix. For a 2 by 2 matrix, how do you calculate the determinant? You will have to cross multiply. 2 into 4 minus 3 into 1. Here we have taken 2 into 4 subtracted with 3 into 1. So you get 8 minus 3, which is 5. So this 5 is the real number or determinant for this particular matrix. Let's take a 3 by 3 matrix. For a 3 by 3 matrix, how do we calculate the determinant? You take the first row. You take the first row elements, right? And then calculate the determinant. First, what we'll have to do is, these are 3 steps. So first you take the first number, which is 2 here, right? Then you ignore the row and the column in which this number is there, 2. Just ignore this row and this column. Then you'll be left with 4, 5 and 3, 6. You'll be left with these elements. So what you'll have to do is take 2, right? And then multiply. Like 2 by 2 matrix, multiply 4 into 6 minus 3 into 5. 4 into 6 minus, so there should always be a minus in between when you're doing this cross multiplication. Minus 3 into 5. 4 into 6 is 24. Minus 3 into 5 is minus 15. Minus and minus is plus. So you get 24 plus 15, which is 39. So we'll get 39. 39 into 2 is 78. Now we'll have to go with the second element. We finished first element. Go to the second element. Now ignore the elements in that particular row where 3 is there. 3 is in this row, right? Ignore this row. Ignore the column in which the 3 is there, right? Now what are the elements that we have left with? We are left with 1, 5, 0, 6, right? Now again, you'll have to cross multiply. 1 into 6 minus 5 into 0. So we'll get 1 into 6 is 6, 0 into 5 is 0. So 6 minus 0 is 6, 3 into 6 is 18. Now we'll go to the third element. Third element is minus 2. Now ignore the row and column in which this particular element is there. So ignore this row and ignore this column. So what do you have? We have 1, 4, 0, 3. 1, 4, 0, 3. Now cross multiply. 1 into 3 minus in between 0 into 4. Right? Minus in between. Always remember to put a minus in between. So 1 into minus 3 is minus 3. 0 into 4 is 0. So you have minus 2 here. So minus 2 into minus 3, which is plus 6. Now one thing we'll have to remember is every number will have an alternate sign. So it starts with plus. First number will have plus. Second number is minus. Third number is plus. So here you will be taking plus 2. Here you'll be taking minus 3. I put minus here. So minus 3 and third element is plus and this element, this number. So you'll always have to remember plus, minus, plus, right? So now what we'll get with this first element, you have 78 as the answer. Second element has 18. Third is 6. Now you'll do 78 minus, because there is minus for the second element. 78 minus 18 and then third element as plus. So 78 minus 18 plus 6. So you'll get 78 minus 18 plus 6, 66. So 66 is the determinant associated with this particular matrix. Actually, you should be doing this way, right? You should be writing it like this. 2 into 4 into 6 minus cross multiply minus cross multiply minus, right? You have to do this way in a line just to make it clearer, right? Just to make it clearer, put like this in 3 steps. Otherwise, it should be done like this. Let's take few examples. say we have this example for 2 by 2 matrix. So how would we calculate determinant? Determinant would be cross multiply 1 into minus 8 and 3 into 5. So we'll get 1 into minus 8 minus in between 5 into 3, which is minus 8 minus 15, which is equal to minus 23. So this is the determinant. Now another example, determinant for this is cross multiply this minus then cross multiply this. So you're going to get 0 into minus 5 minus in between then minus 2 into 3, minus 2 into 3. So we'll get 0 minus and minus is plus. So it's going to be plus 6. So determinant is plus 6. Now let's take a 3 by 3 matrix. 3 by 3 matrix. Determinant for this would be, what we have to do? We have to take the first element. So let's take this element first. First element. This is the first element. Let's take this. So determinant is equal to first element 3. Ignore this. Ignore this row. Ignore this column. Then we are left with elements 2, 4, minus 2, 5. This is what we are left with. Right? So cross multiply this. 2 into 5. 2 into 5 minus. Always remember to put a minus. Then cross multiply this way. Minus 2 into 4. Take this. Minus 2 into 4. So we have finished with first element. Let's go to the second element now. So remember one thing. It has to be plus, minus, plus. So when you take the second element, you have to put minus here. Right? Minus. What is the second element? Second element is 0. Right? So when you have 0, there is nothing. You don't have to multiply. Just leave it. Because 0 into any of this is going to be 0 only. So it's going to be 0. Now let's go to third element. This is the third element. Third element you need to add. That is plus, add it. What is the third element? You have minus 1. Then now what are the elements? Ignore. Ignore the row in which minus 1 is there. Ignore this row. Ignore this column. So you're left with these elements. 1, 2, minus 3, minus 2. So let's cross multiply. 1 into minus 2. So it's going to be 1 into minus 2. Minus should be in between. Minus 3 into 2. Minus 3 into 2. That is minus 3 into 2. Minus should be there in between for determinant. So we have this. Now we'll find the total. Total is going to be 3, 10, 8. 10 plus 8 minus 0 minus, this is going to be minus 1 into minus 2 plus 6. So you're going to get 8 plus 10 is 18. 18 3s are 54. 6 minus 2 is 4. 4 into minus 1. It's minus 4. So determinant is going to be 50. One more additional thing with determinant, right? We have taken first row elements here. It's not necessary that we take first row elements only. We can take second row elements, third row elements. But whichever row you choose, you'll have to complete with that particular row itself. So for example, we took 3, 0 and minus 1 and then calculated this entire determinant. You can also take the second row. You can take 1, 2 and 4. But in that case, if you take 1, 2 and 4, for example, you can find determinant using second row also. Second row or third row. Or you can even use columns to find determinants. So for example, say we'll take second row, right? To calculate determinant using second row, what we can do is, we'll take this element. But first remember this, it's going to be alternate, plus, minus, plus. This is going to be minus, plus, minus, plus, minus, plus. But the signs you'll have to remember. So if you're taking second row, the first element would be 1 here, 1. And you have minus here, you have to take minus here, into, now you'll have to ignore this row in which this element is there. So you'll have to ignore this and this. So what you're left with? You're left with 0, minus 1, minus 2, minus 5. Now you'll have to cross multiply. You have to cross multiply this 0 into 5 minus, what you have? Minus 2 into minus 1. Now go to the next element. Next element is plus 2. Plus 2. Now you'll have to ignore second row and second column. That is, ignore this. So what we are left with? We are left with 3, minus 1, minus 3, 5. These 4 elements we are left with. So cross multiply. 3 into 5. 3 into 5. And then minus 3 into minus 1. Now let's go to the third element. Third element is minus 4. For third element, we'll have to ignore column in which this third element is there and the row. So what we are left with? We are left with 3, 0, minus 3, minus 2. Now cross multiply this way. 3 into minus 2 minus 3 into 0. Minus 3 into 0. 0 into 5 is 0. Minus is going to be plus 2 and again minus 2. This is going to be 15 minus 3 plus 3 minus 3. So this is going to be 15 minus 3, which is 12. This is minus 2. 3 minus 2, 3 into 2 minus 6. This is 0. So we'll get minus 2 into 1. Minus 2 into minus 1 is plus 2. Plus 2 into 12 is plus 24. Minus 6 into minus 4 is plus 24. We are getting 50. We got 50 as the determinant value. Notice this. What we got in the earlier example, when we calculate determinant using first row also, we got 50. Calculating determinant using second row also, you will get 50. That is why even if you use a third row to calculate determinant, you will get 50. You can also do it column wise. Even if you do column wise, you will get 50. So best way, now which row you will choose? The best way to choose a row is choose a row in which there is a 0. So in this case, because if you choose a row which has 0, your calculations will reduce. Now let's take one example where we have to find the value of x, right? So using determinants. How will we do? Determinant is equal to cross multiply. X into x is x square. 4 into 4 is 16 and minus in between, right? And they've told it is equal to 0. Basically they've told determinant value is 0. Determinant value is 0. So x square is equal to shift 16 this side. So it's going to become plus 16. Therefore, x is going to become square root of 16. Therefore, x is going to become 4. But this can be plus or minus 4 because plus 4 square is also 16. Minus 4 square is also 16, right? Whether you have plus 4 or minus 4, when you square it, it's going to be 16. So that's why you will have to put plus or minus 4. Let's do the same thing for 3 by 3 matrix. That is, we have to find the value of x. So what we will do, we'll have to find the determinant. So we will have to, let's use the first row elements. Because x is in the first row, we will use first row elements to calculate the determinant. So basically determinant is equal to, what is the first element? First let's remember, we'll have to put plus, minus, plus, so that we don't forget the sign. So first element is plus 2, right? So we'll put it as 2 into, what are the elements left? Ignore this row, right? Ignore this row and this column. We are left with 1726. 1726. So 1 into 7 minus 2 into 6, right? Now we'll go to the second element. Second element is minus x. For second element, we'll have to ignore this row and this column. So what are the elements we have? We have 4, 6, 1, 7. So cross multiply 4 into 7 and 1 into 6 minus in between. That is 4 into 7 minus 1 into 6. 1 into 6. Now let's go to the third element. Third element would be plus because we have plus here. Plus 3 into, ignore this column and this row. So what are the elements we have? We have 4, 1, 1, 2. Now cross multiply 4 into 2. 4 into 2 minus 1 into 1. 1 into 1. So what do we get? And they've told the determinant value is 0. So basically this is equal to 0. Now we'll calculate 2, 7 minus 12. 7 minus 12 is 5 minus x into 28 minus 6, which is 22, plus 3 into 8 minus 1, which is 7. This is equal to 0. That is nothing but minus 10 minus 22x plus 21 is equal to 0. So minus 22x, 21 minus 10 is 11, plus 11 is equal to 0, which is shift 11 this side. So you're going to get minus 22x is equal to minus 11. X is equal to minus 11. Shift 22 here. So it's going to be division. So it's going to be, get minus also this side. So it's going to be minus plus half. So value of x is half. Properties of determinants. Let us go through properties of determinants. The first property states that the value of the determinant remains the same if the rows and columns are interchanged. That is, let's assume that this is the matrix, and determinant of this particular matrix is represented as determinant 1, right? So you find the determinant, right, using the normal determinant calculations. That is, you take the first element, right, A1, ignore this row and this column, then you are left with this particular matrix B2, B3, C2, C3. Now you multiply B2 into C3, right? You cross multiply B2 into C3, then subtract it with C2 into B3. Similarly, let's go through second element. Second element would be A2. Let's ignore this particular row and this column. What is that we are left with? We are left with B1, B3, C1, C3. So we multiply B1 into C3, then subtract it with C1 into B3, right? So A2 into B1 C3 minus B3 C1. So this will be plus, this will be minus, this will be plus, right? So every element will have alternate signs. You start with plus, then it's minus, then plus, then minus, then plus, minus. So it goes like this for every element. So it's going to be minus A2 here. Now let's do the same thing with element 3, right? So with element 3, knock out this particular row and this column. So we left with B1, B2, C1, C2. So multiply B1, C2 and subtract with C1, B2. A3 into B1, C2 minus B2, C1. So now this is the determinant for this particular matrix. Now what we'll do as a step 2 is interchange the rows and columns. So you take the row A1, A2, A3, represent it as column. You represent A1, A2, A3 as column. Then B1, B2, B3 as column. C1, C2, 3 as column. So now you have interchanged the rows and columns. So whatever rows were here, you have made it as columns in this particular matrix. Now you calculate the determinant. Say determinant 2, right? Same process, you calculate determinant 2. Now if you observe both these, right, it will be same. It is exactly same. You can verify that determinant 1 and determinant 2 are same. So basically this means that the value of determinant remains the same even if the rows and columns are interchanged. Let's take an example. Say this is the matrix, right? Now we need to find the determinant. Let's call this as determinant 1. So determinant 1 would be 2 into, first it should be plus, minus, plus. 2 into 0 into minus 7 is 0, minus 4 into 5, which is 20. Then we go with, there has to be a minus sign for the second element, minus, into, what is the second element? We have minus 3. Now into, so we have elements 6, 4, 1, 7. 6, 4, 1, 7. So 6 into 7 is minus 42, minus 4 into 1, which is 4. Now next element, third element is 5. 5 into, if you strike out this row and this column, we'll have these many elements. So now you'll cross multiply. 6 into 5 is 30, 0 into 1 is 0, minus 0. So we'll get the determinant as 2 into minus 20. 2 into minus 20 is minus 40, minus 42 minus 4 is minus 46, minus 46 into 3. Minus 46 into 3 is 138, and minus and minus is plus, and then another minus. So you have minus 138. Then 30 minus 0 is 30. 30 into 5 is 150. Now further simplifying this, we get minus 28 as the answer. Now we'll interchange the rows and columns. So we have 2 minus 3, 5. We'll put it as a column. Next row is 604. We'll put it as column. Next row is 1, 5 minus 7. 1, 5 minus n, put it as a column. Now we'll find the determinant. Let's call this determinant as determinant 2. Determinant 2 is, take the first element, which is 2, right? 2 cross multiply. 2 into 0 into minus 7 is 0, minus 4 into 5 is 20. Now we'll go with the second element, which is 6. Second element is 6. So we ignore this row and this column. The elements are minus 3, 5, 5 and minus 7. Let's cross multiply. Minus 3 into, first of all, we need to remember it's minus here. The element is 6. And then you cross multiply minus 3 and minus 7. So it's going to be 21 minus 5 into 5, which is 25. Now we'll go with the next element, which is plus, because there is plus here, plus 1 into, we'll ignore this particular row and this column because we're going to take the third element. It is plus 1 into, cross multiply 3 into 4, it's minus 12, minus 5 into 0, which is 0. So always remember to put minus in between. Multiply, subtract, multiply. Multiply, subtract, multiply. Okay. So what do we get? We get minus 20 into 2 is 40, minus 40. 21, this is minus 4. Minus 4 into 6 plus 24. Minus 12 into 1 is minus 12. So we get minus 28. So if you notice, determinant 1 and determinant 2 is same. Both of these are same, right? So even after interchanging rows and columns, determinant is same. Now let's take the next property, property number 2, which states that determinant changes its sign when any of its rows or columns are interchanged. Basically, if you change one row, if you interchange one row or one column, determinant will have a change in its sign. The earlier property, you interchange all the rows and columns. In this property, when you interchange one row, the sign of the determinant is going to be opposite. It's going to change. So basically, let's say this is a matrix and determinant 1, we are going to calculate. Determinant 1 would be this one, right? When you calculate determinant 1, you're going to get this. Now, you interchange first row. You can interchange any row, right? Say you interchange first row. So, you take the first row and put it in second, and take the second row and put it in first. Basically, you interchange these two rows. When you interchange these two rows and calculate the determinant, you are going to get same terms as this, but the signs are going to be differing, right? So same thing as this, but signs are going to be opposite. So let's take an example and prove it. Let's take the same example, right? The early example. We got determinant 1 as minus 28, right? Now what we will do, step 2 is, we'll interchange any one of its rows, right? We'll say determinant 2 is equal to, let's interchange this row and get it here. That is, we'll say 2 minus 3, 5. First row we'll put it in the second row, and second row we'll put in the first row, like this. So we have interchanged these rows, right? Now let's find the determinant 2. Determinant 2 is, first element 6 into minus 3 into minus 7, which is 21, minus 25, plus minus plus. Next element is 0. So we don't have to calculate anything because it's 0. We'll go to third element, which is plus 4. So remember one thing, always choose, when you're finding a determinant, it's better to choose a row which has 0, a row or a column which has 0. It makes the calculation easier. So third element is plus 4 into 2 into 5, which is 10, minus 3 into 1, which is minus 3. Now when you calculate, you're going to get minus 4 into 6 and plus 4 into 10 plus 3, which is 13. So it's going to be minus 24 plus 52. 52 minus 24 is 28. We got plus 28, right? So determinant 1 was minus 28. After interchanging one row, it became 28, plus 28. So the signs have been reversed. You see the sign has been reversed. Let's go to the third property. The value of determinant is 0 if any of its rows or columns are identical. So basically, if you have two rows or two columns which are identical, that is the elements are same. In two rows you have the same elements, or in two columns you have same elements, then the determinant is going to be 0. So basically, you take a matrix like this. The first row is A1, A2, A3. Second row also will be A1, A2, A3. And say third row is C1, C2, C3. Now we calculate the determinant for this particular matrix. So you're going to get this as the answer, right? So all the terms are going to get cancelled and determinant is going to become 0. We can prove this with an example. Now let's take this particular matrix, right? And put two identical rows, right? So this row and this row, first row and third rows are identical. Now let's calculate the determinant. We'll get determinant 1 as, remember to put this. So we'll get 3 into 2 into 3, which is 6, minus 2 into 3, which is 6. So you got 0 here. We'll take the second element. Second element is minus, because of this, minus 2 into, you have 2 into 3, 6, minus 3 into 3 is 9. Then we'll take the third element, which is plus 3 into 2 into 2, 4, minus 3 into 2, 6. So we'll get, this is 0, this is minus 3 and you have minus 2, this is minus 2 and 3. So it's going to be minus 3 into 2 is plus 6. Again plus 3 into minus 2 is minus 6. So it's going to be 0. So we proved that the value of determinant is 0 when the rows are identical. Same thing is applicable when the columns are identical. Let's go through fourth property. Fourth property states that if any particular row in the matrix is multiplied by some constant number, some scalar, some constant number, say k. For example, this particular row A1, A2, A3. Say it's multiplied by some constant number k. All the elements you multiply with k. Say that you get the determinant for this particular matrix is determinant 1, right? This is the determinant for this particular matrix. Now, what will be the determinant for this matrix? It is same as this matrix. This matrix is same as this matrix, except that the first row elements are multiplied by a common constant, by a common number called as k. So what will be the determinant for this matrix? Determinant 2, it's going to be k into determinant 1. Can prove this. So what we will have to do is, we'll have to find the determinant for this, determinant 1, right? Say take the determinant for first element, a1 into b2 into c3 minus b3 into c2. Similarly, then minus a2 into b1 into c3 minus b3 into c1. Then third element, plus a3 into b1 into c2 minus c1 into b2, right? This is the determinant that we get. Now, you multiply first row with k, right? See, you have this k into a1, k into a2, k into a3. Now you calculate the determinant. It's going to be the same thing. Same thing you can copy paste, just that the elements, instead of a1, it's going to be k into a1, k into a2, k into a3. So now when you try to take the common factor, so for all these three terms, you have k as common. So put k as common here, right? When you take k as common, you'll be left with these terms. And if you notice, all these three terms are nothing but these three terms. So basically, you can write this as k into, all these three terms represent determinant 1. So basically, from 1 and 2, determinant 2 is k times of determinant 1. Now let's take an example. We have two matrices here, this one and this one, right? Let's call the determinant for this matrix as determinant 1 and determinant for this matrix as determinant 2. Now both the matrices are same, except that you can write this matrix as, you can write the first row of this particular matrix as 2 into 2, which is 4, 2 into 3, which is 6, 2 into 4, which is 8, right? Now, based on the property, what should it be? Based on the property, you calculate the determinant of this, 2, 3, 4, right? You ignore this common element, common number, ignore this. When you ignore this, you're going to get 2, 3, 4, right? 2, 3, 4. Now you take this matrix and you find the determinant, say determinant 2, and you find the determinant of this one also. So what should we get based on the property? We should get determinant 1 is 2 times of determinant 2. This is what you're supposed to get. Determinant 1 is 2 times of this determinant 2. So let's prove this. Now let's calculate determinant 2 first, right? Determinant 2 is equal to, let's take third row. Let's take third row because this has 0 in it. So it makes the calculation easier. So first element in third row is plus 2, right? First of all, we have to write the signs. Signs for third row is plus, minus, plus, minus, plus, minus, plus, minus, plus. So signs for third row is plus, minus, plus. So we'll take plus 2 into, elements we have is 12 minus 8. Then second element is minus 1 into the elements 2 and 4, that is 8 minus 4 into 1, which is 4. So we'll get, this is 4, this is 4. So 2 into 4 is 8, 8 minus 4. We get 4 as determinant 2 value. Now, so this is determinant 2. Determinant 1, but based on the property, determinant 1 should be 2 times of determinant 2. 2 times, because 2 is the common factor here. So 2 times of determinant 2. So basically, determinant 1 should be 2 times of 4, which is 8. This should be the determinant 1 value. Now let's prove that. Let's calculate. Determinant 1 is, let's take this third row, first element. So this is going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. So it's going to be plus 2 into 6 into 4, 24, minus 8 into 2, 16. Then second element is minus 1. This is a second element. Minus 1 into 4 into 4, 16. Minus, to make it easy, let me ignore this particular row and this column. It's going to be 1 into 8, which is 8. So now when you calculate, 24 minus 16 is 8. 8 into 2 is 16. Minus 16 minus 8 is 8. 8 into minus 1 is 8. So we'll get 8 as the answer. So we got 8 as a determinant 1, which is what we wanted. We have proven this particular property. There is a fifth property which states that if you have a matrix like this, say, right, and you have one particular, and the elements of any particular row or column is expressed as a sum of values, right? Suppose like this, a1 plus x, a2 plus y, a3 plus z. Suppose you can represent any row or any column like this as the addition of two terms. If you can do that, then it will be same as calculating determinant like this. It is same as, you split a1, a2, a3 into one particular matrix and x, y, z into another matrix, right? And then when you calculate determinant of this and determinant of this, it's going to be same as calculating determinant of this, right? That is, you calculate determinant of this, it's going to be same as this determinant plus this determinant. So we will calculate determinant as we normally do. The first element is a1 plus x, into b2 c3 and minus c2 b3, cross multiply. Then take this is plus, this is minus, this is plus. Second element would be minus into a2 plus y into cross multiply this one and this one, b1 c3 minus c1 b3, right? The third element is a3 plus z into cross multiply this b1 c2 and minus into c1 b2, right? So this is a determinant. So what you can do is you can expand it. How would you expand this? You will say a1 into this one plus x into this one, then a2 into this one plus y into this one, a3 into this whole thing plus z into this whole thing. So basically you split all of this like this, a1 into this whole expression plus x into whole expression. Then you have minus a2 into this whole expression. Then you have minus and plus, which is minus y into this same expression. Similarly, you expand a3 plus z also, right? Now, you can calculate determinant for this, right? You remove x, y, z, and then you can calculate determinant for this matrix. So, in earlier properties, we calculated. When you have a1, a2, a3, b1, b2, b3, c1, c2, c3, we have the determinant already, right? We have calculated determinant here, right? This is the determinant for this particular matrix, right? So now, as a next step, you can calculate determinant for this matrix, and then when you add up, you will get all of these same terms, right? Now, we can prove this using an example. Let's take this particular matrix, right? I can write this matrix 3, 5, 7 as, I can write it as 1 plus 2, right? And then I can write it as 3 plus 2, and I can write it as 5 plus 2, correct? I can write it like this. Basically, I want to add some number to this, right? Some number to this. And now I can write this determinant as two separate determinants. Say I can write it as 1, 3 and 5. And the second one is 2, 2, 2. I can write it like this. And the remaining elements, I'll just copy. 1, 2, 4, 1, 2, 4, 2, 1, 0, 2, 1, 0. So basically, the property states that if I calculate determinant, say this is determinant 2, and say this is determinant 3. So, and this is determinant 1. The property states that determinant 1 is determinant 2 plus determinant 3. I have split these two numbers, 3 as 1 plus 2, 5 as 3 plus 2, 7 as 5 plus 2, and I have splitted it like this. 1, 3, 5 in this particular determinant and 2, 2, 2 in this particular determinant. Let's verify it. Now let's calculate determinant 1 first. Determinant 1 is equal to first element. Let's take third row because third row has a 0. It becomes easier. So first element is 2. 2 into sign is plus. 2 into 5 into 4, 20. Minus 7 into 2, 14. So you've taken these two elements, right? Now, next one is minus. Minus 1. Minus 1 into, let's strike out. Minus 1 into 3. 3 4s are 12. Minus 1 into 7. And 0 we can ignore, right? So we'll get 20 minus 14 is 6. 6 into 2 is 12. 12 minus 7 is 5. So we'll get minus 5, which is 7. So this is determinant 1. Now let's calculate determinant 2. First element is 2. So plus 2 into 3 4s are 12. 5 2s are 3 4s are 12 and 5 2s are 10. So minus 10. Minus 1 into, strike out this. 1 into 4 is 4 minus 1 into 5, which is 5. So I'll get 2 into 2, 4 plus 1. So which is 5. This is determinant 2. Let's calculate determinant 3. Determinant 3 is plus minus plus. Determinant 3 is 2 into 2 fours are 8 minus 4. Then minus 1 into 2 fours are 8 minus 2 into 1, 2. So I'll get it as 4 twos are 8 minus 6, which is 2. So determinant 3 is 2. Now, if you notice, add this determinant 2 and determinant 3. This is what we are supposed to be adding. Determinant 2 and determinant 3 when we add. So determinant 2 plus determinant 3 is 7 and determinant 1 is 7. So the property is proven that determinant 1 is determinant 2 plus determinant 3. Let's take another property, property 6, which states that if each element of a row or column is multiplied by a scalar is nothing but a constant number, and added to the corresponding elements of another row or column, then the value of the determinant is unaltered. So suppose we have this particular matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. If we can write one row, say any row A1, A2, A3, like this, in this form, right? If we can express row 1, right, by taking row 2 or any other row, right, say B1, B2, B3, and if you can multiply this B1, B2, B3 with a common constant, say K, with a common number, right? So if you can express this particular row like this, right, that is, you take another row elements and then multiply with one particular constant number and then add it with this particular row. If you can express that row in this form, then the determinant of this and determinant of this is same, right? So in the earlier property, we saw that when you have something like this, where you have sum of two terms, right, you can express, basically you can split it. You can split it as A1, A2, A3 like this. You can split it into two determinants, right? You can split it as A1, A2, A3 and KB1, KB2, KB3. So you can split this. We saw this in the earlier property and we proved it also. Now, so KB1, KB2, KB3, you can take K as a common factor outside. There is a common constant, common number multiplying one particular row, then you can take that common factor out. You can take this common factor out and then calculate the determinant, right? So we saw that in the earlier property. So now here in this property, first we have splitted it up. Once we split it, we can write this as K outside and we can write the other elements. Now what happens here? There are two rows which are identical. Another property which says that for two identical rows, the determinant is 0. Determinant is 0 for this, if two rows are identical. And K into 0 is 0. And then we are left with determinant of this particular matrix, right, which is determinant 1. Let's take an example and verify this. Let's say this is a matrix 5, 9, 15, 1, 2, 4, 2, 1, 0. Now let's call the determinant of this particular matrix as determinant 1, right? Now we will express this 5, 9, 15 using another row's elements, right? Let's take second row, right? We'll take second row here and then also multiply the second row with one common number, scalar, common number, say 2. So 2 is the common number, that is K, right? And we'll take the second row elements, 1, 2, 4, 1, 2, 4. So 2 into 1, 2 into 2, 2 into 4. Now, what should be the determinant? Determinant should be this one. This should be the determinant. The final determinant value should be determinant 2 for us. Whatever you get determinant from this calculation should be the final determinant, right? This determinant 3 does not matter, right? Because simple. You can say you have determinant 3. Let's calculate this. This is going to become 0 because I can take 2 outside. If I take 2 outside, I'll be left with 1, 2, 4, 1, 2, 4, 2, 1, 0. Now, because there are two identical rows, this is going to become 0. So, becomes 2 times of 0, which is 0. Determinant 3 is 0. Now, determinant 1 is nothing but determinant 2. Let's find out determinant 1 and let's find determinant 2. The value should be same. So, determinant 1 is equal to, let's take the third row, right? Absolute plus, minus and plus. So, it will be 2 into 36 minus 15 into 2 is 30. Then minus 1 into, let's knock off this, minus 1 into 5 fours are 20 minus 15 into 1 which is 15. So, you'll get 6 and 5. 6 into 2 is 12. 12 minus 5 which is 7. So, we get determinant 1 as 7. Now, let's calculate determinant 2. So, let's take the third row again. Determinant 2 is 2 into 5 into 4, 20. 20 minus 7 into 2 which is 14. Then minus 1, this one minus 1, 3 into 4, 12, minus 7 into 1, 7. So, you'll get 6 into 12, 12 minus 5 into 1, 5. So, you got 7. So, we notice this determinant 1 and determinant 2 have the same values. We have proven that whenever you can express a determinant as a sum of two terms where one term is nothing but the element of the other row and you multiply it with a common constant, right? Then the determinant is nothing but same as this one, A1, A2, A3, this one. So basically KB1, KB2, KB3 can be ignored. Your determinant will be same as A1, A2, A3, B1, B2, B3, C1, C2, C3. Let's go through property number 7. Property number states that if all the elements in a row or column are zeros, that is, if any row or column has zeros, then the determinant is 0, right? Like this. So here we can prove that. Actually, if you take third row to find the determinant, then everything is going to be 0 into 0 into 0 into. So obviously it's going to be 0. We can also take row 1 and prove this. Let's take row 1, A1, A2, A3. Let's take A1 as a first element. So it's going to be B2 into 0 minus C3 into 0. Then we'll take second element minus A2. Minus A2 is going to become B1 into 0 minus C3 into 0. And third element A3 plus A3 into B1 into 0 minus B2 into 0, right? Now when you simplify, you're going to get 0 as the answer. Now let's go through property number 8. Property number 8 states that if all the elements on any one side or both sides of the principal diagonal are zeros, then the value of the determinant is equal to the product of the elements in the principal diagonal. So this is the principal diagonal. That is, from the left top to the right bottom, the elements that you see in the diagonal, is called as a principal diagonal. This is the principal diagonal elements. Now, if you see that on one side of the diagonal there are zeros, or both the sides of the diagonal there are zeros, the determinant is nothing but it's a product of the principal diagonal elements. What are the principal diagonal elements here? It's A1, B2, C3. So if you multiply A1, B2 and C3, that's going to be the determinant for this particular matrix. So that is what we can prove here. We can take, say, first row, first element A1 into B2, C3 minus B3 into 0. Cross multiply this. Then minus A2 into cross multiply. So you knock off this and this. So you'll get minus A2 into 0 into C3, which is 0, and 0 into B3, which is 0. Then you go to the third element A3. Then you'll get 0 into 0 minus B2 into 0. So basically, finally you're going to get determinant 1 is A1 into B2 into C3. So these are all properties that we need to use while calculating problems, because this is an easier way to find the determinant. If you know that there are zeros on one side, then directly say determinant is A1 into B2 into C3. Now if you see that there are in one particular row or one particular column, all the elements are zeros, then the determinant is 0. So this way we can simplify the problems. Let's take few examples to calculate determinants, right? Now, there are a few operations that can be done on matrices, right? One is interchanging rows and columns. You can interchange row and column, right? You can take row 2 and make it as row 1, take row 1 and make it as row 2. The second operation is you can add and subtract. You can take row 1 elements and add it with row 2 elements. Similarly, you can do subtraction. You can also multiply, right? You can multiply row 1 elements with some number, with some constant number, and update or modify the new row, right? So here you can club addition and multiplication. Here you can do multiplication. So these are the operations that you can do on rows and on columns also. It is just not rows, you can do it on columns also, like this, right? C1 plus 2 C1. C1 is C1 minus 2 C2. This is 2 C2. And C1 is 2 times of C1. To modify row 1, you're going to take row 1 elements, then multiply 2 with row 2 elements, and then add both of this. So let's take this particular example, right? Now, see, we can always calculate determinant directly like this, right? You can multiply this, subtract and multiply this. You'll get the determinant. But these are huge numbers. We'll have to do this using determinant properties or by simplifying it. That is, how do we simplify it, right? Without using the actual determinant calculation, right? We can simplify the matrix. So what we can do is, we can make the number small and then use any one of the determinant properties. So what we can do is, let's call this as row 1, this as row 2. So what we can do, we can subtract row 2 elements, right, like this. So we'll say row 2, we can write row 2 as row 2 minus row 1. Row 2 as row 2 minus row 1. So that will give us, we'll keep row 1 as it is. We're not going to modify that. Only row 2 we are going to modify. So row 2 is, we'll say 2013, we'll do it, 2013 is the first element, minus row 1, which is 2011. So we'll get 2. So this will be 2 here. Then for second element also we'll do that, 2014 minus row 1 element, which is 2012. You'll have to take the corresponding element. That is, if you're taking second element in row 2, you'll have to take second element in row 1. If you're taking first element in row 2, you will have to take first element in row 1. So now 2014 minus 2012 is 2. Now we have a determinant property, right? You can take 2 as common factor. One of the determinant properties is you can take 2 outside, right? Any scalar number which is same, you can take it outside. So if you take 2 outside, don't modify the first row, only the second row will get modified. You take 2 outside, it's going to be 1 and 1. So now we'll use the determinant calculation. What is the determinant calculation? 2 into 2011 into 1 minus 2012 into 1, which is 2 into minus 1, which is minus 2. So this is the determinant value. So you can also directly do this multiplication, but that is not what is expected here. What is expected here is you will have to simplify. You will have to make the number small and use determinant properties, right? But even if you directly calculate, you will get the same answer. So you can try that out. That is, if you directly calculate the determinant, you will get 2011 into 2014 minus 2013 into 2012. I have just calculated and tried out. You will get the same answer, minus 2. So instead of using such huge numbers to calculate, what is expected is we simplify or make the number small. Now let's take another example here. This is a 3 by 3 matrix, right? In this matrix, we'll have to simplify the numbers. Again, we'll use those row operations, right? This is row 1, row 2, and this is row 3. What we can do? We will have to somehow make the number small, and then we'll also have to use one of the determinant properties. The most important determinant property is making the rows identical. If you make the rows identical, determinant is going to be 0. Determinant is 0 for identical rows. So let's try and check if we can make the rows identical, right? Now we can perform row operation. Say we'll take row 2. Row 2, when you subtract with row 1, you're going to get 3. Now for 6, you can take common factor as 2, and then you'll get 3, 3, 3. Rows are going to become identical. Let's solve this step by step. So first one, we'll take row 2, right? This means you're going to modify row 2. How you're going to modify row 2? You're going to take row 2 elements. You're going to take row 2 elements subtracted with row 1 elements. Then you'll also do another operation. You'll take row 3 elements and take row 3 elements subtracted with row 1. So now let's apply this. Row 1 is not going to get modified, right? We leave it like that, 81, 82, 83. 2 minus row 1. So let's take the first element, 84. 84 minus first element of row 1, it is 3. Then second element of row 2, 85. Subtract with second element of row 1, 85 minus 82, 3. Now third element of row 2 with third element of row 1, 86 minus 83, 3. Same thing we'll do for third row. Third row is going to be, first element is 87. 87 minus row 1, which is 6. Then 88, this is second element. You take the second element in row 1. 88 minus 82, which is 6. Similarly, third element, 89 minus 83 is 6. Now we can take 2 as common factor. We saw one of the determinant properties is you can take the common factor out, right? Determinant will be k times the determinant. If you're taking 2 as common outside, say 2 as outside, so you'll get 3, 3, 3. And then you'll have 3, 3 here, 81, 82, 83. So you have 2 identical rows. Because there are 2 identical rows, determinant becomes 0. Let's take another example which states that show without expansion. Show without expansion the determinant is 0. Without expansion means using the normal determinant calculation. That is, you take the first element, cross multiply, take the second element, cross multiply, third element, cross multiply. So without using that entire determinant calculations, we will have to prove the determinant is 0 using the properties and using row operations or column operations. Now there are 2 properties, or there are 2 ways in which the determinant becomes 0. When the rows are identical. 1. Identical rows, right? And second thing is when any row or column has all zeros. In these 2 conditions, determinant is 0. Either we'll have to make the rows as identical, or we have to make any row or column as all zeros, right? So what we can do is we can add columns here. This column, this column, this column. We can add, or we can add rows here. Let's try to add the columns here. Let's try to add column 2 and column 3 with column 1. Column 2 and column 3 with column 1. Because if you somehow can make that column 1 as 0, right, then the determinant is going to be 0. So let's add. So you can make C1. This is column 1. C1, C2, C3. Column 1 as column 1 plus column 2 plus column 3. Let's do this. So we'll get A minus B plus B minus C plus C minus A. Then let's copy column 2 as is and column 3 as is, right? Let's copy this as is. Now, second element in the column B minus C. B minus C, you add it with column 2, C minus A, with column 3, A minus B. Then we take third element in column 3, C minus A, plus A minus B, plus B minus C. So now what's going to happen is, A and A is going to get cancelled, B and B is cancelled, C and C is cancelled. Here also same thing, B and B is cancelled, A, C, C. Everything is cancelled. So we got 0 here. So now we got 0, 0, 0. And then B minus C, C minus A, C minus A minus B. Just copy this. Now, since we got zeros in one column, since one column is all zeros, determinant is 0. You'll have to write. Since C1, column 1 has all zeros, determinant is 0. Since C1 has all zeros, determinant is 0. So we have used the determinant property to prove that determinant is 0. We have not used determinant calculation, but we have used the determinant properties. We used column operations to determine the determinant. We can do the same thing with row operation also. So with row operation, it's going to be row 1 is going to be row 1 plus row 2 plus row 3. If we do this, in that case, one particular row, this row 1 is going to become all zeros, right? So this is another alternate way of doing this. Here there's another example where we have to show the determinant is 0 without expansion. So straight away, we can know that we can take common factor. First thing is, let's check if we can take common factor every time, right? So here you can take, first row you can take 3 as common, right? First row you can take 3 as common. Second row also you can take 3 square as common. Third row you can take 3 to the power 4 as common, right? Now when you're taking multiple common factors per row, then you have to multiply all of this like this, right? So if you take 3 in the first row you've taken 3, so you'll be left with 1, 3 and 3 square. Second row you take 3 square, so you'll be left with 1, 3, 3 square. Third row you've taken 3 to the power 4, so you'll have 1, 3, 3 square. So now you see that there are all 3 rows are identical. Since the rows are identical, determinant is 0. Since rows are identical, determinant is 0. We will go through several such examples in the next video. Thanks for watching. Hope this video was useful.